Hello and welcome to TidyX episode 125. TidyX's screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward, and we're excited to be here with you. Remember, like and subscribe on the YouTube channel. And the reason why that's important is because, as you'll see in today's episode, we got some great feedback on the previous episode. And so we're going to follow that up today with answering questions, discussing some of the user information, and hopefully, if you like and subscribe, you can also help shape future episodes because we actually think that's really cool. Because then instead of doing stuff that we're just interested in, we're doing stuff that we're interested, but you are also interested in.
Yeah, so hopefully it helps you out. That we
Yeah.
can come up with examples that help you as most as possible. And also by liking and subscribing, that tells the YouTube algorithm that this video is helpful for folks and will hopefully show it to more folks, who then just kick cycles a way through and gets people just more excited about this project that we've been doing.
Yeah.
So let's get going into the episode today. And so,
Yeah.
like we said, this is episode 125. This is following up on what we did on our last episode, episode 124, where we showed how you might be able to use multiple conditions, or you might combine multiple conditions together to generate your new data set. And so somebody saw that video, apparently liked it, and then went onto our GitHub page. So we have a GitHub where we throw all the code that we have from every episode into its the bioengineer slash TidyX. And Data Davids opened an issue with a new suggestion on how you might be able to approach dealing with this sort of problem. So let's walk through this and how it works because we thought it was a really interesting way to approach this. So the first thing that David does is, you may remember in our episode, we had several different fruit types, such as apple, orange, banana, pear, kiwi, cherry, grape, and we were trying to come up with a list, or trying to come up with a new column that would
Yeah.
say what seasons do we like them in. Is that, I forget the exact reasoning behind
Uh,
it, but
yeah.
it's pedantic. It doesn't really matter. The idea
Yeah.
was is that we had these multiple values that we wanted to paste together, but not every fruit showed up in every season. As you can see,
Yeah.
apple shows up in every single season here, so winter, summer, spring, but orange only appears in winter, and pear only appears in summer. But then some of them appear in both of them, like, or in two of them, like banana. So how do you write your code such that you can combine winter, summer, spring together in a nice into a nice string that says winter, comma, spring, comma, summer for apple, but then winter, comma, spring for banana, but then for pear only show summer. So that was the problem that we were dealing with. And so we showed a number of different methods. Definitely go over and check that out. But David Davids came up with this solution here, which where they took the information that we knew, which is we knew for apple that's a winter, and made it into a list where the name of the list was the season, and the entries of the list element were the fruits that were to be assigned to that season. And then you generate that list. It's called LST1. Then you throw it into enframe. So enframe is an interesting function. I've personally not used it very much, but what it does is it converts this list into a data frame where the names of this list. Read the documentation. It's a complicated function, but for our purposes in this example, what it's doing is it's going to construct from the names of the list, so winter, summer, spring, it's going to call that a new column called, it's going to generate a tibble where the column is going to be called season. It's going to be winter, summer, spring. And then the values, so the entries in this list, will go into another column of that tibble called fruit.
Yeah.
And
So
it's a
can we
list column.
run? Yeah. Can we just run the
Yes.
list
Yeah,
by?
that might be
Let's run the
easier
list by
rather
itself.
than trying to explain it. So
Yeah.
yeah, so
So
it goes like this. And so winter has these three entries in it. And so
yeah.
this fruit is now a list call.
Because if you just ran the list by itself, right, all it's done is it's basically nested those. So it said, hey, take winter and all of the elements, all three elements in winter, collapse them into a list, and then take summer and collapse those 4 into a list. And so that's what the end frame basically did, right?
Yep.
Yeah.
Yep, exactly. And then you can use the unnest function, and that is going to take the nested functions or the nested entries in the fruit column, which is what we've got here, and it'll spread them out like that. And so winter will now then, if let's rerun that, have the 3 entries for apple, orange, banana, and we can have all those guys there. Then we can do this group by fruit, and so this will group by apple, and then collect all the apple versions, and then we're going to do a summarize by each fruit and go, okay, now we're going to use this toString function. And this toString function, if you pass a vector to it, it will convert it into a character string for us using this formatting function. And so we can do toString on a, see if it helps if I can type A, B, C, and it combines them into a nice, actually printed format there for us.
And we probably could have also used maybe paste with collapse if you did group by fruit. I think you could probably have used paste.
Yes, you could have done that as well.
And then collapse, I think that would have worked as well.
Yes,
either way.
This is also an option. I tend to default to this because this means I have more finite control over what's going on here. But toStrings, it looks like it works too. And let me undo my changes. Let's show how David's had their data, and there we go. We got apple, and this is the same answer that we were showing earlier. And so just wanted to call this out as a very interesting way, and this is why we like interacting with you all and sharing, and people commenting, sharing their code, so we can show different ways to approach problems.
Yeah, that's cool.
At some point you may be working on a problem, you're like, oh, I remember that solution. I know how somebody does this. And this is a cool way to do it. Next, we got another interesting question where I used rowwise in our example to allow us to do things rather than grouping by fruit. And so you can do this is you just use the rowwise function. And what this does is this adds a class or makes this empty cars data set where it looks and prints kind of like normal, but it is actually a rowwise df. It's also a tibble df, tibble, and data frame. Let's not worry about that. But basically what a rowwise df is implicitly a grouped df, but the grouping is for every row. But don't confuse the two. It's not a grouped df. But you can use a lot of the same functions that you normally do with that. And so you can use summarize, you can use mutate, you can go and use it as you normally would. Just know that operations are done by each row. But what if you want to, what if you've completed all your group-wise operations in your by row? How do you make it no longer do that? Well, you use the ungroup function. So just as if you were using a group by and we were grouping by fruit and we were done doing operations by fruit, but we weren't done doing our data manipulations, you call ungroup. And so you can call that, and it is now an ungrouped data set we can see there, and now it's gone back to a tibble df, tibble, and data frame. But equally, if you're not done with doing group-wise operations, but you're done doing it by row, you use the group by function itself to say, okay, now we're done doing group by row. We're now going to do group by. In this situation, we're using the empty cars data set, so we're going to do it by cyl, so by the number of cylinders in your data set. And so this then takes it back. It's now a grouped df. It's no longer a row-wise df. But that is how you could approach using, go and use mutate, use summarize, use whatever functions you're doing makes sense for your data manipulation needs. But when you're done doing it row-wise, you can use ungroup to simply be done with those group-wise operations, or use group by to override or reset what grouping variables are used. Yeah,
effectively that cancels out the row-wise grouping. So you could essentially go here and say group by cylinder and then do, summarize the mean miles per gallon per cylinder or something like that. And it'll do it by cylinder without barking any sort of warning or error at you because you've overridden the previous.
Yes. And I
Yeah.
do know this was answered in the comment section. So somebody did ask this and somebody did answer this in the YouTube comments down below. So, but I think it was N1Loon. So their username is N1Loon. So thank you for answering that. Thank you for asking that question as well. Like we said, great community. Our community is fantastic where we help each other out so much on answering these coding questions. And so you should definitely like and subscribe.
Mm-hmm.
But then we got one more question that we wanted to bring up with folks. Patrick, I'm going to let you take us through this one.
Yeah, so this one was submitted on the YouTube channel from Jeff Rothschild, who's he's working on a PhD in physiology and nutrition in New Zealand, but I think he's an American. And he submitted this. He had some data. He's got some RPE data, and basically he has RPE data in one scale, which is a traditional what's called the Borg scale, which goes from 6 to 20. And so he submitted this saying, I've got data like that, but what I really want is for it to translate to the CR10 scale. So basically, he wanted to make a 1-for-1 swap. So he says, when you see a 6 on the Borg scale, that's a 0 on the CR10 scale. When you see a 7 on the Borg scale, that's a 1, an 8, a 1.5, all the way up to a 10. And that is going to yield a 20 on the traditional Borg scale. So he was saying, how can we do this? And we can solve this with a left join. The first thing is, you set up your little RPE key up at the top. So that basically is mapping your Borg, your original 6 to 10 Borg scale. It's mapping it to the new number that you'd like to reflect instead. And that new number is what we want to build as a third column within our data set. So we've got a data set that has participants, their Borg RPE value, and we want to map onto that the CR10 value. So we take our subject data that we create here as a tibble, where we're basically passing in some fake subject numbers, participant ID numbers, basically, and their Borg RPE values. So you can see those 6 to 20 right there. And now we're just going to left join in that RPE key that we created. So here we take that subject data, we're going to left join by RPE key, and we're going to join by, in the left data set, in the subject data set, we're going to join by RPE, and in the right side, we're going to join by the Borg scale. So those are the numbers that R is going to look for those values to match up, and when they match up, it's going to deposit that CR10 value into the furthest column, the new column. So that's what we end up with here. And then all we did was we just gave it a little rename. So instead of calling it CR10, we just said, well, let's just call it transformed RPE, since it's not the direct CR10 value in the study, right? It's actually transformed from a different value. So just being transparent about that. And so running all those 7 lines of code, now you see, so anywhere there was a 9, we get a 2. Anywhere there was an 8, it's a 1.5, etc. And so this is a really easy way to do that. So that's three kind of questions and comments from episode 124, which is super cool. If there's more questions about this kind of stuff, or additional stuff, or more complex versions of this stuff, just like everyone who reached out after episode 124, feel free to drop that in the comments section or the GitHub repo. That's always open as well.
Exactly. So I think with that is all the content that we planned for this episode. And we look forward to doing more episodes going into the holiday season. And with that, I guess we're going to call it. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. At Tidy_Explained is where we are both tweeting on Twitter. Tidy.explained@gmail.com is where you can hit us up on in email. On the GitHub repo, if you'd like to open up an issue, you can go ahead and do that. Most common way that people are trying to reach out to us is on the YouTube channel. So if you like and subscribe, drop your comments down below. We'll get to those and maybe turn them into an episode. Just as Jeff's example here, anytime you can send some sort of a small data set that looks like the data that you're working with, that's always way helpful for us. And if there's new stuff you want to take a look at, stuff you're stuck on, stuff that's complicated that you're challenged with, and you want to get some help, feel free to reach out to us there. And as always, if our show has been some way impactful and beneficial to your career, and you'd like to support us, we do have a Patreon page, and we're always appreciative of anything that you offer.
Yeah, thank you all so much, and keep on exploring your world.